All right, on to problem 4. Now, the goal on any of these equations is to get x by itself. That's what we're doing. That's what we've been doing for a long time. So I'm going to read this to you. This says 12 times all this garbage, which is the fifth root of 3x minus 1, 12 times all this stuff equals 24. Now, we need to clear out this 12 first. This says 12 times. What is the opposite of multiplication? 12. I mean, division. The opposite is division. So what happens here? This cancels out. Those two go away. I am now left with this, which is awesome. And remember, for those who are curious, Mister, I don't see another exponent here. There's nothing here. There's nothing here. Remember, fill in your own 1. That's what's there if there's nothing there. 24 divided by 12 is 2. Here I go. I'm going to go ahead and rewrite this into exponent form. This is going to be 3x minus 1 raised to the power of, this is the denominator, 5 is the denominator, and 1 is the numerator. Now I can go ahead and raise this one more time. Now that I've done this, I'm going to raise this to the power of 5 over 1. Because it's the reciprocal, I'm going to raise it to the power of 5 over 1. 5 over 1. But if I do it on one side, I must do it on the other side. That's a weird 5, but welcome to my life. 5 over 1. So this is pretty cool because now this 3x minus 1 and this 1, 5, these things cancel out. That goes away, and I am now left with 3x minus 1 equals 2 to the 5th power. 2 to the 5th. 2 times 2 times 2 times 2 is actually equal to 32. And if you typed it in, you'd have 32 for that. So that is equal to 32. Now this is a regular equation. I'm going to add 1 on both sides. I'm going to add 1 on both sides, and I get 33. 3x equals 33. Divide the 3 out. Divide the 3 out. Sorry, I'm running out of room. I did this too messy at the end. X equals 11. You should be able to do this part from here on without my help. X equals 11. You have to plug this back in and check if it's an extraneous solution. I don't want to do it or not, so right now at this moment. So you can tell me, is this extraneous? Is this extraneous? Or is it a solution? Which one is it? You tell me how to do it. Question mark. All right, now I'm going to go ahead and move into example 5. I'm going to go ahead and move into example 5. Here we go. Now, I have this x plus 12 to the 1/2. All right, at this point, y'all, you know what? Let me clear the annotations here. At this point now, y'all, we should understand the reciprocal. So if I'm going to get rid of that exponent, I'm going to go ahead and raise it to the power of 2 over 1. But remember the rule. If I do it on one side, I must do it on the other side. X squared. All right, cool. I end up with x plus 12. So let me get that back up. I end up with x plus 12. X plus 12 equals x to the power of 2 is x squared, y'all. X squared. This is where it gets real fun. This is where it gets real fun. And here we go. When you have an x squared inside your equation, this is a quadratic equation now. Anytime you introduce a x squared into an equation like we just did here, you end up squaring it and causing things. You are definitely going to introduce some sort of extra solution. So with that said, how do we solve quadratics? Y'all, this is going to be painful. You got to get everything. You got to get everything on one side. You got to get everything on one side with 0 on the other side. So when you move everything over, move the x over, move the 12 over, you end up with 0 equals x squared minus x minus 12. And now you have to break this down with factoring. How do you do that? You get your a, you get your b, you get your c, you get your ac. A is 1, b is -1, c is -12, ac is -12. So it's got to mult to that and add to that. What does it add and mult to? Let's see. -12, -3, and 4. I think the numbers are going to be -4 and 3. -4, 3. That's definitely what it is. So watch how I do this. We've been doing the shortcut method where we don't group, but I'm going to show you how to get this done. We're going to break this -1x right here into these two terms. So the next step after we find these numbers is this. X squared. I'm going to type in my -4x plus 3x minus 12. So notice, I don't know if y'all remember doing this. This is the way we're going. I have now turned this into this. I've turned this into this. Negative 4x plus 3x is negative 1x. They're the same thing. But I'm able to then, at this point, factor by grouping. I'm going to able to, at this point, factor by grouping. And that's what I'm looking to do, is factor by grouping. So on this little thing right here, I can pull out an x, and I end up with x minus 4, which is awesome. On this one, I can pull out a positive 3. So I'm going to pull out a positive 3, and I end up with x minus 4. And here's what's cool. Here's an x minus 4. Here's an x minus 4. And here's my leftovers, x plus 3. So watch my answer. I end up with x plus 3 and x minus 4 equals 0. Then you can solve, and you end up with, you have to set each of these equal to 0. So you end up with x equals negative 3, and you end up with x equals 4. Basically, just switch the signs if you didn't see what I did. X equals negative 3, x equals 4. And now you have to plug these both in to check for your answers to see if it works. So I'm going to let y'all plug that in yourself and tell me which one's the extraneous, which one is the extraneous, which one is the extraneous, and which one's the solution. Which one is the solution? I'm out of time this morning, so I won't be able to model 6 on these videos, but I can tell you right now, the first step you want to do is you're going to move the 5 over. I will probably make this video later in the day to make sure everybody has it, because I think it's kind of important. It's a hard one. But with that said, I'm out of time. Class is about to start.